All right, this is lesson 7-7. We're talking about scale drawings and models. So we're taking all of what we learned about proportions and similar shapes, and we're applying them to actual things like buildings and people and things like that. So more word problems. This says continued because there is a front side to this worksheet. I typically do one video of the front, one video of the back, but the front here is the exact same thing as this. However, for a scale model, we'll talk about it in a second, instead of it the front side telling us how big the scale model is, it actually has us get a ruler out and measure with the ruler. So that's the only difference, is doing that extra step. You might have a question or two like that, but typically it's going to be like this where it gives you the measurements. Okay, so it says, use scale factors. The scale factor of a drawing or scale model is the scale written as a unitless ratio in simplest form. Scale factors are always written so that the model length in ratio comes first. So model to actual. When we write a ratio for a scale factor, we write the size of the model over the size of the actual. Okay, the other thing that I want to make sure you know is that when you're comparing the model of something, let's say it's a building and you're building a little, 12-inch tall model and it's of a 25-story building, right? You have to make sure your units of measure are the same. So we don't want to do inches up here and feet down here because our scale, it's not comparing apples to apples. We want to make sure that your units of measure are the same. So units of measure the same. I'll show you what I mean when we get down here into an example. Okay, so we have our first example, a scale model. A dollhouse that's 15 inches tall is a scale model of a real house with a height of 20 feet. What's the scale of the model? So first of all, with the scale, we're not doing anything yet. We're not comparing anything yet. They did go ahead and leave it in inches and feet. I would argue that you need to take it a step further and change it to the same unit of measure, okay? But if you see them give you information and they leave it like this, just know they're doing the same thing we're doing. They're just not taking it quite as far as we are, okay? So the model length, the smaller version, and the larger version goes on the bottom. Smaller version goes on top, larger version goes on the bottom always. Okay, so our model dollhouse is 15 inches. Our actual house is 20 feet. So our scale factor here, when we simplify this, is 20 inches over 4 feet, okay? But we're not comparing apples to apples here, right? So if we have to start asking questions about it, which we're gonna do here in a second, you can't leave it like this. You have to put them either both in feet or both in inches, okay? When we're talking about scale drawings and scale models, you have to have them in the same units of measure. So I'm gonna change them both into inches, right? If I change them both to feet, I'd have a fraction on top of this fraction. So I'm gonna change them to inches. So the top is already in inches, 3 inches, done. The bottom is in 4 feet. So we are going to change that number on the bottom, but we're not changing what the 4 feet represents. We're going to replace it with something equal to 4 feet, right? How many inches are in a foot? 12. So we're going to multiply 4 feet times 12 inches, and that'll tell us how many inches are in 4 feet. So I'm going to multiply the bottom by 12. I'm not going to multiply the top by anything because it's already in inches. So I'm just going to leave it the same, right? You don't even have to write that. We're not going to touch the top. It's already in inches, okay? I know the big argument here is, well, what about a fraction? When you change a fraction, whatever you do to the bottom, you got to do to the top to make them equal. We're not changing the value of this fraction. 3 inches over 4 feet is the same thing as what we're about to write, but instead of putting it in terms of feet, again, we're putting it in inches. Okay, so 3 inches stays 3 inches, and 4 feet, if we put it in inches, is what, 48 inches. So this is 3 inches over 48 inches, right? It's the same thing as 3 inches over 4 feet, same thing. Okay, but now I can simplify this, right? So I can divide the top and the bottom by 3 since they're both in the same units of measure. Now, since they're in the same unit of measure, whatever I do to the top, I have to do to the bottom. Now I am changing the value of the fraction. So 3 divided by 3 is 1. 48 divided by 3 is 16? Yep, 16. Okay, so great. What does that mean, right? This means, remember, the top is our model measurement, and the bottom is our actual measurement. So the top was our dollhouse, the bottom was the actual building the dollhouse is a scale model of, right? So the model is 1/16 the size of the actual building, right? We could stack 16 models on top of each other for it to be the same height as the actual building. So how much larger is the actual building than the model? It's 16 times bigger. 16 models will fit in the actual. I hope that's making sense to you guys. Okay, so when we go to this next step, you'll see that's exactly what they did. How many times as tall as the actual house is the model? Remember, model's on top, actual's on bottom. So they went ahead and changed 4 feet. They put it in terms of inches. So 48 inches is still 4 feet. It's the same fraction, just looks different. So 3 over 48, when we simplify, is 1/16. Okay, so how many times as tall as the actual house in the model? Here we have the scale factor. So the model is 1/16 the size of the actual house, right? The actual house is 16 times bigger than the model. The scale factor is 1 to 16. That is, the model is 1/16 as tall as the actual house. They left off a 1 there. I feel like I'm beating a dead horse. I hope that's making sense. All right, so let's just do 3 examples here together, okay? Same kind of thing. A model train. The length of a model train is 18 inches. Here, I'll highlight that. The model is 18 inches, and the scale of, the actual train is 48 feet. Okay, so remember when we write our ratio, we write model over actual. So that's yellow over orange. Okay, so if we're filling in these numbers, that's 18 inches over 48 feet. Feet. An 18-inch train is a scale model of a 48-foot train, right? But I can't leave it like that. I want to put them in the same units of measure, right? So inches is on top. Can I change 48 feet? Can I put it in terms of inches? Yeah. Okay, in 1 foot, there's 12 inches. So in 48 feet, I got to multiply it by 12 to see how many inches that is, right? And if I multiply that out, I already did it on my paper over here. Boom, boom, boom. I don't see where it is. 12 times 48 equals 576. So that's 18 inches on top. That's still in terms of inches. We don't have to change anything. And 48 feet is the same as 576 inches. So our scale to our actual, the model train compared to the actual train is this ratio. Now we can simplify. And I can actually, since they're in the same units of measure, my fraction is 18 over 576, and I can actually divide the top and the bottom by 18 evenly. So 18 divided by 18 is 1. Let me scoot that over. And 576 divided by 18 is 32. So this is the actual scale factor. The model train is 132. That size of the model train is 132. 1 over 32, I don't know how to say that, 1/32 of the size of the actual train. If I added this fraction up, 32 times, 1 over 32, if I kept adding it up 32 times, so 32 of these models, it would add up to 32 over 32, which is 1 whole unit, 1 whole actual train. 32 models adds up to 1 whole actual train. So model over actual. Okay, number 2, art. An artist in Portland, Oregon makes bronze sculptures of dogs. That's great. The ratio of the height of a sculpture to the actual height of the dog is 2 to 3. So remember, it's model over actual. So the sculpture over the actual dog. And that ratio is 2/3. If the height of the sculpture is 14 inches, then find the height of the actual dog. So X. And we're finding it in terms of inches, right? So we're gonna cross multiply this guy, and we're gonna cross multiply this guy. So I get 2 times X is equal to 3 times 14. 2X is equal to 42. Divide both sides by 2, and X equals 21, and it was in inches. So if the sculpture is 14 inches, how big is the actual dog? 21 inches. And you say, well, that's super close. That's not like we just talked about a train, you know, whatever. Well, yeah, it says that the scale factor, the scale model is 2/3. So for every 2 units of the model, there's 3 units of the dog. They're going to be really close. The sculpture is going to be really close to the actual size of the dog. So it makes sense. Okay, and then lastly, number 3, a bridge. This is going to be kind of like the train example. The span of the Benjamin Franklin Suspension Bridge in Philadelphia, Pennsylvania is 1,750 feet long. A model of the bridge has a span of 42 inches. What's the scale factor of the model of the span of the actual Benjamin Franklin Bridge? Okay, so we're looking for that fraction of model over actual. And in my word problem, I'm just going to highlight the model is 42 inches. The actual bridge is 1,750 feet. Okay, so we can write this as 42 inches over 1,750 feet. And then stop there, and that's it. And we don't keep simplifying it, right? This is the scale factor. But then we want to take it further, and we want to make sure they're in the same units of measure. So the top's in inches. I'm not going to touch the top, but I do need to change the bottom to inches. So that's 42 over, and that is 21,000. Don't believe me. Let's do it together. 1,750 times 12. 21,000. Okay, 42 over 21,000. And I can actually simplify this. I can divide the top and the bottom by 42. All right, so once I do that, 42 divided by 42 is 1. 21,000 divided by 42 is 500. 21, I don't know why I cleared that off, divided by 42 equals 500. Okay, and this is in inches. So for every 1 inch of the model, there's 500 inches of the actual bridge, right? Makes sense. And if you wanted to put it back in terms of feet, which I don't know why you would, but 500 divided by 12 would be almost 42 feet. So for every 1 inch of the model, there's about 42 feet of bridge. Makes sense, right? That makes sense. So our scale factor of our model is 1 over 500 when they're in the same units of measure. If they're different units of measure, you can leave it like this, but you have to label the units of measure. And up at the top of this paper, it said when you're talking about a scale factor, it's a unitless measure, right? So you got to make sure you're talking apples to apples and not measuring it in different units. Okay, I hope that makes sense. If you have any questions, let me know.